Alright, today's lesson is a little more challenging because we are going to be writing the piecewise functions based on the graph. So let's look at what we have here. It says write a piecewise function to represent the absolute value function. So I want to write something that represents this. Okay? So let's think about this for a second. F of x. Alright? Well, whenever I put a negative x in, so x is less than 0. Okay? What happens when I put a negative 1 in here? Hopefully you guys say you get a positive 1 out. If you put a negative 2 in, you get a positive 2 out. Same thing if you keep going. So, for all negative x values, the function is not x because I want it to change. So what sign do we need to put in front for it to change? We need a negative sign. So think about it. Now if I input a negative 1 here, I get what out? Negative of a negative is a positive. So this piece will represent all the negative x values of an absolute value function. For just the middle point, it's 0, right? When x equals 0, it's 0. Or you know what? You don't even have to do that technically. You could just say you can put an less than or equal to 0 there, and it's the same thing, because when you put 0 in, you get 0. And then when we go over 0, x is just x, because positives stay positive, it doesn't matter. So this would be a piecewise function that could represent an absolute value function. Don't worry too much about that. I just wanted to talk about it to show you that you can write absolute value functions in pieces instead. It's almost like saying this first piece is negative x is this line here. This is this piece. The second piece is x, and that gives you your full absolute value function. So this was your green piece, and this is your blue piece. Alright, but this is where it gets challenging. So, you know, this is the function you can use, and we need f of x equals. So, we need to represent this graph. Now this is where you have to know your lines, know everything that's going on. What I like to do is separate them by domain. So I have f of x is equal to, I have my bracket, my blue piece x is at negative 6, but it's less than. So x is less than or equal to negative 6. My other domain for green is from negative 6 to negative 1. And finally, my third graph goes from negative 1 all the way forever. So x is bigger than or equal to, because it's a filled in dot, negative 1. Perfect. So now we have that. Here's how I do this. You basically look at this graph and go, okay, this is a line. The slope of this line, you always work slope going from left to right. The slope would be down 3 and over 2. Okay? So we know it's the m for the blue one is negative 3/2. Now, I know this line doesn't keep going, but if you want to find the y-intercept to make life easier, you can just have the graph keep going. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. If this graph were to continue, which it doesn't, the y-intercept would be negative 7. So I can make this function f of x equals negative 3/2 x, that's my slope, minus 7. That's my y-intercept. That is the equation of this full line if we extended it, but I only want the line that is less than negative 6. Alright, for green that's pretty easy. It's a horizontal line, which means we just have a number, and that number is 3. F of x is equal to 3 when we are there. Now, this next one's an absolute value graph. This is where knowing that vertex form comes into play. This vertex of the absolute value graph is at 5, negative 2. And remember, we always take the opposites for that. Well, opposite for the inside and the same for the outside for that. And now you just need to come up with the slope. The slope is 1, 2, 1, 2, 3, 2/3 of an absolute value graph. Now, the only thing that's different is which way is the absolute value facing, up or down. It's down, so it's going to be a negative. So, we can just throw this together then. I have a negative 2/3, an absolute value of x. Since it's shifting to the right, it's the opposite sign. And then shifting down is the same sign, so down would be minus 2. And there's my absolute value graph. So those are my three pieces. All I did was I worked backwards. I knew how to make an equation of a line using a graph. I knew what a horizontal line was, and I knew how to do absolute value from 2 lessons ago. Again, this form is very important, the vertex form. You'll be seeing it in quadratics as well. Alright, so let's look at this next one. Now this one's a little bit more challenging because I don't know what... Oh no, the second part will be more challenging because if you see the y-intercept, we don't know what that is. But we do have 2 points, so we can make it work. Alright, so I have f of x. I have my bracket. That was a terrible bracket. And we need equals, by the way. It has to equal something. Hopefully I remembered that. If I didn't, yeah, I did. Alright, so let's put in our domain first of all. The first one is x is less than -3, not equal to. The second one, x goes from -3 to 5, and they're both equal to because they're filled in. And finally, the last one is a horizontal line from 5 onward. X is bigger than 5, but not equal to because there's no filled in hole. So, now we are going to come up with our equations. This one, again, get the slope first for lines. 1, 2, 3, 4, 1, 2, 3. So we have a slope of 4/3. And let's see if we can find the y-intercept. I'm going to do it again. 1, 2, 3, 4, 1, 2, 3. Oh, if this line would continue, it would hit at 0. So my y-intercept is 0. So this is just 4/3 x plus 0, or you can just leave it as 4/3 x. That's my first part. Done. Now, this is the one that's a little trickier. This is where you have to go to point slope form to actually solve it to get the correct answer. First, get the slope. You can always get the slope if you have 2 points. 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. So 2/8, or the slope is 1/4. Okay? And now I'm going to use point slope form down here to actually solve for what it is. I'm going to use the point -3, 0. And the slope of 1/4. This is stuff you did on the first quiz. We're just going to try to get a slope-intercept form equation. So, I get y minus 0 is equal to 1/4 x plus 3. If I solve this, I get y is equal to 1/4 x plus 3/4. This is the equation of that green line. So I could just take that, because I already have y equals with the f of x, and say it's 1/4 x plus 3/4. And again, all I did was I found the y equal equation using one of the points and counting out the slope. Finally, we have a horizontal line. It's at y equals 4, so this is a 4. And that is how you work backwards for those, okay? For graphing when you have those pieces there for you. Okay, just plot them by coming up with the slope and using a point. And then the absolute value, you just have to know the vertex form. Alright, so now we have 2 word problems. This is all they're saying is shipping costs $6 on purchases up to $50, $8 on purchases over $50, and up to $100, and $10 on purchases over $100 and up to $200. Write a piecewise function for these charges, give the domain and range. So let's talk about this. We have the function is equal to, we're going to have 3 pieces here. The first is shipping costs $6 on purchases up to $50. So that means our x is between 0 and 50. Now up to means we include 50. Think about this. Do we want to include 0 for this part? You can think about that. Maybe pause, take a quick second to think. Why would we want to or not want to include 0? Well, think about what's happening here. This represents the shipping cost, $6, whenever I buy something between 0 and $50. It wouldn't make much sense to include 0 because that means you're not buying anything. It would kind of stink if you were just sitting there and all of a sudden they're like, I'm charging you $6 shipping on nothing. Okay? So we don't want to actually include $0 because you're not actually buying anything then. And so you're not getting charged $6. So you got to think in terms of real world sometimes with that. Alright, the next piece. $8 on purchases over 50 and up to 100. So I have $8 that are at 50 and up to 100. And finally, $10 for anything starting at 100 but not actually being equal to 100, and up to 200. So this should be your piecewise function. And again, this represents shipping costs whenever the x is your purchases between 0 and 50, 50, 100, 100, and 200. So our input values are our domain. Our domain are the x values, such that x goes from 0 all the way up to 200. And the range here is just 6, 8, or 10. Those are our 3 possible outputs for this problem. Okay, so that is why we use piecewise functions sometimes in the real world. Things like this, where you have different levels depending on what you buy or what you how much you're using. Okay, so that is that problem. So let's do the last one then. A plane descends from 500 feet at 250 feet per minute for 6 minutes. All right. So let's start at 0 for this plane. I'm going to just write my piecewise function up here. And the first part is from 0 to 6. I hope you guys see that. The plane is doing something from 0 to 6. It is starting at 5,000 feet. This we can call our starting point or our y-intercept. So whenever you're modeling a linear equation, you're starting at 0. You want the y value to be your y-intercept, and this is your slope. However, think about it. Descend means, is it going up or down? Well, hopefully you guys know descend means you're going down, which means your slope should be negative. So the first part of this whole thing is actually pretty easy. I have a negative 250 slope times wherever it is between 0 and 6 minutes, plus we started at 5,000 feet. So that is the thing that models the flight of the plane for the first 6 minutes. Now, over the next 8 minutes, not 2-8, but the next 8 minutes, we are flying at a different rate. First off, the reason why these are both equal at 6 is because the plane doesn't automatically just jump up or down to another value when it's flying. It's flying, it's descending from 0 to 6, and then at 6, it's still at the same spot. It's not shifting anywhere, but now its slope changes. Okay, so we have to take that into consideration. Now, the first thing you have to figure out is where is the plane at 6? Okay, we need to know where this plane is at. So if we were to graph this, for instance, we need to know where it is. So I'm going to look at that on my calculator real fast. Okay, so I have negative 250x plus 5,000. Now, the graph you won't be able to see it. You won't be able to see it because our window is all messed up. But we can look at the table. That's the important thing. So at 6,000 or at 6 minutes, the plane is at 3,500 feet. Okay. Now this is where you do not make the mistake of just writing down. This is, so at 6 minutes, the plane is at 3,500 feet. So that is our new point for starting this new second line. And the slope of the new second line is negative 150. Now, what you do not do is you do not say it's negative 150x plus 350, or 3,500. Because 3,500 is not the y-intercept of this line. It's the information at 6. So you have to come up with the equation yourself using point-slope form. So why don't you guys try that while I do that? Y minus 3,500 is equal to the new slope times x minus 6. And when you solve this, you should get plus 900. And then you add 3,500 over, and you get y is equal to negative 150x plus 4400. And all that means is that if this plane we're always doing negative 150 slope, if you worked your way back to 0, it would hit at 400 or 4,400. Okay. So again, we do not put 3,500 here because this is not the y-intercept. It's the value at 6. Okay. So we now have our piecewise function. We have two equations that meet the requirements, and we're good. And then it just says, what is the plane's altitude after 12 minutes? Well, look on your chart. 12 falls in this range here. in this domain, I should say. So we use that function. So f of 12, and we did this yesterday, is negative 150 times 12 plus 4400, and you should get that equal to 2600 feet. And again, label everything you can when you're dealing with word problems. Okay, so that is Piecewise. Using Piecewise with word problems. Hope you guys enjoyed, and I will see you tomorrow.